Resale is a $174 billion global market, yet selling your own stuff remains a nightmare. Preparing a listing is a slow, tedious process. Casual sellers lack market insights, which leads to wrong pricing and lost money. Worst of all, duplicating ads across multiple marketplaces forces you to manually adapt formats and repeat this exhausting cycle over and over. The market is huge, but for regular people, it is just broken. Standard software fails peer-to-peer selling due to chaotic, unstructured data. Traditional programming breaks under this unpredictability, while standard chatbots only force users into tedious back-and-forth dialogues. Ultimately, listing requires complex actions, image analysis, market evaluation, and cross-platform copywriting. Monolithic models hallucinate trying to handle this pipeline simultaneously. The SellerAI architecture is built on top of Google ADK. Its main goal is to take a seller's photos and a brief description, and automatically transform them into live listings across multiple marketplaces simultaneously. Crucially, it keeps the seller in control at two strategic decision points. At the core of this system is a sequential agent called the listing_orchestrator. It manages a single, four-stage pipeline. These stages communicate forward strictly through a shared session state, session.state, ensuring there are no direct calls between agents. Let's break down these four stages step by step. Stage 1 is intake. Here, a multimodal AI agent reads the provided photos and text just once. It then generates a single platform-agnostic product schema that serves as the foundation for everything else. Stage 2 is the safety gate. This is a global screening layer. If any harmful content is detected, a hard guard instantly halts the entire run, preventing any downstream actions. Stage 3 is the pricing round. The system computes a unified price. Then, it pauses for the first human-in-the-loop gate. It requests price approval from the seller, who can either lock it in or send it back for a reprice. Stage 4, the final phase, is the publish round. Preparation for each marketplace kicks off in parallel branches. For every single platform, the system sequentially runs a security analysis, writes the listing, and double-checks compliance. Before anything goes live, the system pauses once more for the seller's final stamp of approval. Whatever the user approves is immediately published, while the rest goes back into a rewrite loop. For this demo, we use a mock marketplace that exposes its own REST API, running on localhost on port 3000. The user is already logged in. The agent system is configured up front, user parameters and platform settings live in their respective JSON config files. Launch the Google ADK agent web interface to start the workflow. Upload the item photos and an optional short description. The intake sub-agent identifies the item and writes a short description. The item is checked against the compliance rules. Next, the pricing agent inspects the reference marketplaces from the user config and calculates a suggested listing price. The user is asked, "Is the price acceptable?" If not, the price is recalculated taking the user's input into account. Once accepted, the price is locked. The same price is reused for every platform. Once the price is accepted, the publishing agent runs for the target platform. It writes the item description following that marketplace's rules. It evaluates the marketplace's acceptance rules. The finished listing is shown to the user for approval. After the user approves, the listing is published to our marketplace. The development started not with code, but with writing a clear architecture description of the whole photo-to-listing flow. From that we designed the multi-agent pipeline. Next we turned the architecture description into a concrete implementation plan, mapping each piece onto concrete tasks and specifying our tech stack. We then had the plan implemented by Claude Code and Anti-Gravity CLI, building the pipeline, the connectors, and the live publishing integration, right in the terminal. Finally, we moved to testing and refinement. A deterministic, offline test suite let us iterate fast.